Hi guys. 7.3 is a hard nut to crack, so I thought I would make a video and walk you through your homework. Before I do that, I want to review quickly what we learned in class. In this unit, we learned three things. This is the graph that's most familiar to you. We've learned that when we have a big right triangle ABC and I draw an altitude, I split that big triangle into two additional smaller triangles, and they're all similar. So we're going to review that. We also learned about altitude being the geometric mean, or one of the legs being the geometric mean. So I'm going to get into more details of that. Before I do that, I want to make sure that that you know that in this video, I'm going to discuss some approaches that we haven't discussed in class. You should be able to understand what Mr. Stanton said in class, and you should also be able to use the approaches the tricks I try to show you. They're interchangeable, and it really helps you if you can do both. Okay, so here's some quick review. Remember what's a fraction? A fraction is, a ratio. A ratio is just a fraction. 2/3 is a ratio. A over B is a ratio. Okay, proportion is when two ratios equal each other. So when we say 2/3 equals 4/6, that's a proportion. This whole expression is a proportion. And when we say A over B equals C over D, that's a proportion. Remember, we call B and C, because this can also be written as A to B equals C to D, and these can be written as A to B, or 2 to 3, right? Remember, the ones in the middle is what we call mean, and the ones on the side are the extremes, right? Now, there is a special proportion that makes life a lot easier, is when the mean is being repeated. So A over B equals B over C. You notice that B gets repeated, so we call B the geometric mean. That's what geometric mean means. A and C are still the extreme. So that's a quick review. Now let's look at this. So I've got a big triangle ABC, and I've got the altitude BD here. Therefore, I create three right triangles. A smaller one, like the green one here, and a middle one, like the yellow one here, and my big one, original one, ABC. But if I'm asked to write a similarity statement of the three, I have to find the matching angles. So how do I do that? Here's a trick that you can use. Okay, I like to use this trick. If I look at my original triangle, my big right triangle ABC, B is my right angle, 90 degrees, right? I'm going to put A with a 1 tick mark. I'm going to put 2 tick marks on C. So I wrote this triangle in the order of 1 tick mark, right angle, 2 tick marks, 1 R2. Now, I'm going to look at my yellow triangle. In my yellow triangle, I already have a right angle. I already have 2 tick marks. The only angle left, I can only put 1 tick mark there. Now, if I write the similarity statement, I have to go to 1 R2. So that's B, D, C. These two triangles are similar. Now let's look at my green, little smallest triangle, right triangle. I already have a right angle here. I already have 1 tick mark on A. What's left can only be 2 tick marks. So this triangle, if I go 1 R2, 1 is A, R is D, 2 is B. I have right triangle ADB, who is similar to the other two right triangles. So again, start with the original big triangle, then work your way through it. So let's try this again. I have my original triangle as triangle ABC, and I'm going to mark it. You can mark it either way. You can mark A with 2 tick marks. As long as you're consistent, you're good. Okay? So I marked A as 1, C as 2. in the middle triangle, I already have my right angle. I already have 2. What's left behind is 1. And in my smallest triangle, I have right angle. I have 1 on A. What's left behind is 2. So since my original angle ABC, I went 1, R2, I have to do the same in my middle triangle. I have to go 1 is B, R is D, 2 is C. And my smallest triangle, 1 is A, R is D, 2 is B. So that's how I find my corresponding angles and write the similarity statement correctly with the right order of the angles. So as you can tell, the big triangle A and middle triangle, in the middle triangle, this angle B, and then in the small triangle A, these 3 angles are exactly the same. They're congruent. So now we know that they're similar, we can write congruent statements. And if I'm given a problem, especially when I'm given information about this BD altitude, right? Notice that if I have BD as the altitude, look at this small triangle, ABD, in this small triangle, in this yellow triangle here. Notice that if I set up a proportion BD over AD, in the small triangle, that's what I'm doing, BD is the longer leg. Long leg. AD is the short leg, right? Now if I go to my middle triangle, let me try a different color, middle triangle in green, notice where is in my middle triangle, where is my long leg? In the middle triangle, the long leg is DC. In the middle triangle, where is my short leg? It's BD. So I can set this proportion up like that because this yellow smallest triangle and the middle triangle are similar. I can use long leg over short leg over long leg over short leg. Now you can't flip it the other way too as well. So let me write it the other way too, maybe even better. I'm going to write it in black ink, okay? So let's look at this small triangle. I'm going to start with my short leg. My short leg is AD. In the smallest triangle over my longer leg is BD because my hypotenuse is AB, right? So I'm ignoring the hypotenuse. I'm only looking at the short leg over the long leg, okay? Short leg over long leg. Now I look at the middle triangle. My short leg is BD. My long leg is DC. Do you notice that however I set it up, I have my BD, which is my altitude, as my geometric mean. That's where it comes from. Okay? Also, I want to tell you that some people call this a heartbeat theorem. The reason for that is, look at this. If I go by this sequence, I go BD, BD over BD. I'm sorry, AD over BD equals BD over DC. So I go by heartbeat, right? I go to the first segment AD and then go up to BD, then equals BD again, then come down DC. It's like the in the hospital what they use, like a heartbeat. So they call this the heartbeat theorem. So that's another way to remember this. But this is what Mr. Stanton say, that as you can see, this is where the geometric mean comes to play for the altitude. The altitude in this heartbeat, you have to go AD over BD, then BD over DC, and they equal each other. The altitude is repeated, and therefore that's your geometric mean there. So now let's look at the last thing we learned. It has something to do with legs. What it is that if no information is given about the altitude is useless, right? So, but generally in that case, we will be given information about the hypotenuse and the legs in each triangle. So we have to utilize those. Now, if I look at my big triangle, my hypotenuse is AC, and then let's pick this small leg. It's AB. I can set up a proportion like that. So it's hypotenuse over small leg, shorter leg. Now, because I picked the smaller one, I'm going to look at this smallest right triangle. Notice that the hypotenuse in that is AB, and the shorter leg in that smallest right triangle is AD. Now I just set up a proportion using AB, which is one of the legs of the big right triangle, as the geometric mean. Now, I can do the same on this side. If I use AC again, is the hypotenuse over in this case is the long legs, right? The long leg in the big triangle is BC. Now, because it's the long leg, I'm going to look into the middle triangle. In the middle triangle, my hypotenuse is BC over my long leg in that triangle is CD or DC. Notice again, my BC, which is the middle, the long leg, is the geometric mean in this case. So if you want to rewrite them, you can. You can say the shorter leg equals AC, which is the hypotenuse, times AD, which is the segment adjacent to the shorter leg. And in this case, it's BC squared, which is the longer leg, is the geometric mean, equals AC, again the hypotenuse, times DC, which is the segment adjacent to this leg. Okay, so I know this is a lot of concept. Mr. Stanton has taught this a couple of times this week. But if you just keep in mind that these three right triangles are similar, you can set up proportions. If information about altitude is given, then you use the Heartbeat Theorem. If no information about the altitude is given, only information about legs are given, then you just use hypotenuse over the shorter leg and then figure out what the corresponding sides are and figure out your proportion that way. So that's it. And see, let's put it into practice. This is your homework from yesterday. You have x over 12 equals what over 8. So I have x over 12. I should have heartbeat. Notice that my information about altitude is given. So it should be x over 12 equals 12 over 8. This is the geometric mean of altitude. This one, also this is information about altitude is desired. I don't have this part. This is also heartbeat. I don't have this part, but I can calculate. So that's 20 minus 15. This part should be 5. So if I were to set this up, I would do 5 over x equals x over this part is 15. But all I need to do is to use the reciprocal property. 15 over x should equal x over 5 in this case. This one, I probably, do I have, ooh, interesting. This one I have to turn this around, turn the paper around so that this angle is on top. But obviously no information is given about the altitude. So what can we do here? It says 9 over x. What do I do here? Equals x over what? What do you think this is? So notice, if this is the right triangle, isn't x my hypotenuse? And 9 is one of my legs, right? And therefore, when I look at on the big triangle, it should be x is my leg of the big triangle. So this is the smaller triangle. This is the big triangle on the right-hand side. If x is my leg, I got to look for my hypotenuse here. Oops. Hypotenuse, I forgot a y. Hypotenuse here. My hypotenuse is 9 plus 11, so that should be 20 there. Okay, again, I'm going to write it a little better. It should be in this small right triangle. It's 9 over x. 9 is a leg. X is a hypotenuse. So it's leg over hypotenuse. It's 9 over x. Then in the big triangle, the leg is x. The hypotenuse is 11 plus 9, which is 20. Look at number 4. No information on altitude, so I cannot use my heartbeat, I guess. So let's see if I can set up the proportion. I have, using legs, I have hypotenuse 12 over 6 is the leg. Then I'm asked to find A. A is, so I have hypotenuse over leg. A is a leg, right? So A is a leg, it has to be here. And in this smaller triangle, the hypotenuse is 6. There we go. There's my, what we call geometric mean there. So you didn't have to memorize the formula. You just look for hypotenuse over a leg over hypotenuse over a leg in a different triangle. So the outcome is that it's a geometric mean. And that's a nice way to verify your answers. So I'm not going to solve it, and then you guys can solve it. Over here, I've got the altitude. I like it. Every time I have altitude, I can do my heartbeat. So I start with 6 over x equals x. Got to come down to 8. Done. Okay? Cross multiply, use your calculator and solve it. In this one, I don't like this as much. No altitude is given, so I have to use legs. Legs is hypotenuse over leg. Hypotenuse is 24 over leg is 10. In here, hypotenuse in the smallest triangle, hypotenuse is 10, and then B is the shorter leg. So again, you can solve your cross multiply and solve your equation. Number 7, I've got altitude. If I have altitude, I can do heartbeat. So it's 8 over W plus 9 equals W plus 9 over 18. And then solve it. Okay, cross multiply, you should have W plus 9 squared equals 18 times 8. There are different ways of solving it. Let's see if we can do it this way. One way we can do is we can take a square root on both sides. I would have 18 times 8. Then I can factor this inside, see if I have perfect squares. 18 is 2 times 9. 9 is 3 squared. 8 is 2 times 4. 4 is 2 squared. And so I'm going to rewrite this. There are 2 2's here. So I have a 2 squared, I have a 3 squared, I have another 2 squared. Now all of these 2's can cancel with the square root, so the base can come out, and I would have that's 12. If W plus 9 equals 12, I minus 9 on both sides, W should equal 3. Okay? Let's look at number 8. I'll set it up for you. This time, I like it. I've got the altitude in there, so I can do my heartbeat. But make sure you rotate your triangle so that you know your heartbeat goes this way. Okay, so you start with X. What is your heartbeat? Now I can't see. I'm going to erase that. Start with x. X over z equals c over y. Ooh, I now don't like it. Too many variables. I don't know which is which. So what do? I think, this is a tricky one. So I think I've got 14 here. Can I use legs? If I do that, I cannot use legs easily either. So I'm going to use, maybe I'm going to leave this alone and discuss it in class. Okay? Now let's look at this one. Altitude, we like it. If I have heartbeat, right? If I have altitude, I have heartbeat, I can find A. So I can do A over 32 equals 32 over 24. And then solve for A. Once I solve for A, you can use Pythagorean theorem, c squared equals a squared plus b squared. Plug it in. Your b squared is 32, your a squared is whatever the answer is. You can find c. And obviously you can use Pythagorean theorem to find b as well. Okay? This type of question is really important. Tell whether the triangle is a right triangle. If so, find the length of the altitude of the hypotenuse. Round the decimal points. So I'm going to use number 12. See how we do number 12 here. The first thing you need to determine is it a triangle? Remember, the way we do that is we have to take the two longer side, take the two shorter sides added together. So in this case, 6 and root 34. If it's root 36, that will be 6 times 6, so it's about 36, right? So this actually is the longest side, which means I need to do 30 plus 18. 30 plus 18 is 48. Is 48 greater? Because 48 is greater than 6 root 34. Because I just did 6 root 36 would be 36. 6 times 6 is 36. So this is slightly less than 36. So yes, I have a triangle. So yes, I have a triangle. Now I have to plug it into Pythagorean theorem to see if, c squared, is it equal or greater or less than? So c squared is 36 times 34. A squared is 30 squared. B squared is 18 squared. So do your math and remember, if c squared comes out to be exactly the same, I have a right triangle. If c squared is greater than a squared plus b squared, again, notice c squared has to be the hypotenuse. I have an obtuse. If c squared is less than a squared plus b squared, I have an acute triangle. Okay? It's important to know that we put c squares on the left-hand side so that these signs, these inequality signs, are consistent with our impressions of these triangles. It makes life easier. These are the same question. These are actually, believe it or not, relatively easier. Oh, one thing I forgot to mention is this one. If I'm asked to find the altitude, that's what Mr. Stanton was talking about in class. He has a trick. I hope I can remember. So now if I do have a triangle, if I do have a right triangle, I'm not sure if this one is a right triangle. I know this one is a right triangle. So let's suppose if I have a right triangle here, right? So how do you do that? So let's talk about it in class and flip through your notes today. We talked about it, but I'm going to review that tomorrow in class as well. Make sure you complete this homework so that we can actually discuss it. Okay, guys? Thank you. Bye.